Hello and welcome my dear students and biochemistry learners. Welcome to this definition series in biochemistry part 2. In this video, I will be presenting to you definitions in lipids. So let's begin. Lipids. Lipids are heterogeneous group of organic substances that are relatively insoluble in water and soluble in organic solvents such as benzene, chloroform, ether, etc. Simple lipids. These are esters of fatty acids with various alcohols. Neutral fats. These are esters of fatty acids with alcohol glycerol and are uncharged. Example: Triacylglycerol. Waxes. These are esters of fatty acids with higher molecular weight alcohol or long chain alcohols other than glycerol. Example: beeswax. Complex or compound lipids. These are esters of fatty acids with alcohol containing additional or prosthetic groups. They are subclassified according to the type of prosthetic group present in the lipid as follows: phospholipids, glycolipids, lipoproteins, etc. Phospholipids. Lipids containing, in addition to fatty acids and an alcohol, a phosphoric acid residue. Glycerophospholipids. In these phospholipids, alcohol glycerol is present. Example: phosphatidylcholine or lecithin. Sphingophospholipids. In these phospholipids, the alcohol present is sphingosine. Example: sphingomyelins. Glycolipids or glycosphingolipids. Lipids containing a fatty acid, alcohol sphingosine, and additional residue as carbohydrates with nitrogen base. Example: Cerebrosides. Lipoproteins. Lipoproteins are formed by combination of lipids with a prosthetic group protein and help in lipid transportation. Simply, they are molecular complexes formed by the combination of lipids and proteins. Example: chylomicrons. Miscellaneous lipids. Miscellaneous lipids include the lipids which are not classified under any of the previous groups. Example: isoprenoid derivatives, squalene, carotenoids and all. So these are the lipids that show properties of lipids, but chemically they cannot be included in any of the previous group mentioned, like simple, compound, derived, etc. Derived lipids. Derived lipids include the products obtained after the hydrolysis of simple and compound lipids, which possess the characteristics of lipids. Example: ketone bodies. Fatty acids. Fatty acids are long hydrocarbon chains of various lengths ranging from 4 to 36 carbons and the degree of unsaturation that terminates with carboxylic group. Simply, they are carboxylic acids with hydrocarbon side chain. Saturated fatty acids. There is no double bond in the hydrocarbon chains of these fatty acids and are extended conformation, and so can be packed together into a compact structure. So saturated fatty acids do not have a double bond in their hydrocarbon side chain. Unsaturated fatty acids. They contain double bonds in their hydrocarbon chains. They are in cis configuration. The double bond is in cis configuration. This configuration produces a rigid bend in the aliphatic chain and compact packing is prevented. Consequently, the unsaturated fatty acids are loosely packed and are therefore more easily disturbed by heat. Monoenoic or monounsaturated fatty acids or MUFA. Monoenoic or monounsaturated fatty acids or MUFAs carry a single double bond in their hydrocarbon side chains. Example, oleic acid. Polyenoic or polyunsaturated fatty acids or PUFA. Polyenoic or polyunsaturated fatty acids, PUFAs, contain two or more double bonds in their hydrocarbon side chains. Example, linoleic acid. Branched chain fatty acids. A branch is present in the hydrocarbon side chain of these fatty acids. Example, isovaleric acid. Substituted fatty acids. In substituted fatty acids, one or more hydrogen atoms have been replaced by another group. Example, ricinoleic acid. Cyclic fatty acids. Fatty acids bearing cyclic groups are present in some bacteria and seed lipids. Example, colmogric acid. Essential fatty acids or EFAs. These fatty acids, the fatty acids that cannot be synthesized by the humans and therefore should be supplied in the diet. Example, linoleic acid. Humans do not have enzymes that can add double bonds beyond carbon number 9, and hence these fatty acids are not formed in our body. So hence they become essential fatty acids. Sorry. Saponification. Hydrolysis of fat or triacylglycerols by alkali to produce glycerol and soap is called saponification. What is soap? It's nothing but sodium or potassium salts of fatty acids depending upon the type of base used. Hydrogenation. Hydrogenation, chemical addition of hydrogen of unsaturated fats in the presence of a catalyst like nickel. It's also known as hardening. Peroxidation. Peroxidation is auto-oxidation of lipids exposed to oxygen. It is responsible not only for deterioration of foods, that is also called as rancidity, but also for damage to tissues in vivo. Rancidity. The unpleasant odor and taste developed by natural fats upon aging or deterioration is referred to as rancidity. Rancidity may be due to hydrolysis of or oxidation of fats. Saponification number. The number of milligram of KOH required to saponify 1 gram of fat is known as saponification number. It is inversely proportional to the molecular weight of fat. Iodine number. The number of grams of iodine required to saturate 100 gram of given fat is known as iodine number. A high iodine number indicates high degree of unsaturation of fatty acids. Acid number. Number of milligram of KOH required to neutralize the free fatty acids present in 1 gram of fat. The acid number indicates the degree of rancidity of the given fat. Reichert-Meissl number. The number of ml of 0.1 normal alkali required to completely neutralize the soluble volatile fatty acid distilled from 5 gram of fat. The RM value for butter is 26, coconut oil is around 7, and for edible oil, most of the edible oils will have RM number less than 1. Triacylglycerols or triglycerides or simply TAGs. Triacylglycerols are esters of fatty acids with glycerol. They are also referred to as triglycerides, fats or neutral fats. Simple triacylglycerols. Triacylglycerols containing the same kind of fatty acids in all the 3 carbons are called simple triacylglycerols. Example, tristearine, 3 stearic acid at the 3 carbons of glycerol. Mixed triacylglycerols. Mixed triacylglycerols contain 2 or more different types of fatty acids. Example, 1,3-palmitoyl, 2-linolyl glycerol. So palmitic acid at carbon number 1 and 3 and linoleic acid at carbon number 2. Cerebrosides. Cerebrosides are the simplest glycolipid in which there is only one sugar residue, either glucose or galactose, linked to a ceramide and named as glucocerebrosides and galactocerebrosides respectively. Cerebrosides are simply ceramide plus a monosaccharide, and based on the presence of monosaccharide they are named. Sulfatides. Sulfatides are cerebrosides in which the monosaccharides contain a sulfate ester. The most common sulfatide is sulfogalactoceramide, which is found in large amounts in myelin. So sulfatides are ceramide plus monosaccharide plus a sulfate group. Globosides. Globosides contain 2 or more sugar molecules, most often galactose and glucose or N-acetylgalactosamine, attached to ceramide. So globosides are ceramide plus chain of oligosaccharides. Gangliosides. Gangliosides are complex glycolipids derived from glucocerebrosides. Ganglioside contains oligosaccharides and their polar head groups and 1 or more molecules of sialic acid, which is usually N-acetylnuraminic acid NANA, attached to ceramide. So gangliosides are cerebroside plus oligosaccharides and N-acetylnuraminic acid. Cholesterol, animal sterol. It's obtained from the Greek word chole, bile, and steros, solid. So literal meaning of cholesterol is solid alcohol obtained from bile. So cholesterol is the major sterol in animal tissues. Amphipathic lipids, Greek amphi, both pathos, passion. Lipids possessing both polar, that is hydrophilic, and non-polar hydrophobic groups. Example, phospholipids. Liposomes. Liposomes are microscopic spherical vesicles. When mixed in water under special conditions, the phospholipids arrange themselves to form a bilayer membrane which encloses some of the water in phospholipid sphere. Organ-targeted delivery of drugs, proteins, enzymes, genes, etc. may be achieved with the help of liposomes. Emulsions. These are produced when non-polar lipids, example triacylglycerols, are mixed with water. The particles are large in size and are stabilized by emulsifying agents such as bile salts. I am thankful to all these resources for making this video possible. Thank you friends, thank you for watching this video. Be happy, healthy, and most importantly, stay safe. And remember, biochemistry is easy. Thank you so much.